What was the problem you had in the unread files? Has anyone faced any problem with the previous session, like the assets?
Yeah, I think my Crow plugin is throwing some errors after the first session itself.
In which asset or which example?
The second example where we had these 3D in the SOM basically.
Okay.
Yeah, maybe I can share it with you after the session, Sam. If that's
Yeah, that would be amazing, actually. Okay, could you please share it, Mirzad? Could you please share it after the session with me? We could have a little call and see what is going on, okay? So let's get started, guys. Today we're gonna talk about the core of deep learning, or what we call it, the generative adversarial network, or we call it GAN. So before diving or jumping into GAN, we have to understand some fundamentals in the type of the neural network, because we faced I guess two types of neural network, but going into the a new advanced type of neural network needs some kind of explanation before diving into the GAN. So before diving into the GAN basically we've heard about that terminology a lot by generating fake images. We've heard about the deep fake. We've heard about the voice cloning, and that all is GAN. So before jumping into the GAN, we have to understand the hidden neural network that process all the GAN, or all the training or the testing. So have you ever heard about convolutional neural network before, like the CNN? Okay, have you ever heard about the facial recognition, object detection? I believe everyone heard about the facial recognition and the object detection and the image processing and all that happens in the convolutional neural network, what we call it, the CNN. So what does the CNN do? We provide an image. Okay, let's say an image for 5 times 5 times 1, which means 5 pixels by 5, like a matrix, and the one which means it's white or black. So it's one vector for the coloring. So we pass that input image in the convolutional layer kernel, and it processes that image and gives us 3 by 3. So what's happening there? Okay, so let's move forward. So let's take a look. The convolutional neural network depends on the something what we call it a tensor. A tensor, which means could contain a scalar, or could contain a matrix, or could contain let's say a vector, a sequence of numbers or series of numbers. We call it always a vector, and the matrix we call the u and v, and times we multiply between these numbers, we call it a matrix, and the scalar is just one-dimensional value. So let's say we have this image, the green one, and the 1 and the 0 represent if it's white or black. So what do we have here? We have like 5 by 5, and the vector of the coloring, we have only the grayscale, or we call it the brightness. That's why we call it before 5 by 5 by 1. So what happens there, we take a convolutional kernel and we apply it into these pixels in order to extract these the feature of these images. So we multiply that convolutional kernel with the pixels of this image, and we extract these features from the images. So when we have like a lot of darkness or the dark spots in the image, it does multiply this convolutional kernel with the image in order to extract the features of this image. That's why we call it extracting feature or feature extraction. So what happened here, the convolutional kernel goes through this image and try to multiply with these pixels in order to extract all the features in that image. So in the CNN terminology, the 3 times 3, which is the matrix of the convolutional kernel, is called a kernel or feature detector. It multiplies with the original vertices of the image in order to compute and extract these features, and that's what we call it the convolutional extraction, or the convolute feature, or the feature mapping. Okay, so we have that original image, and we multiply with the convolutional kernel in order to extract these feature from the original image. That's what happens in the object detection or the facial recognition. It doesn't like process all the image, it just extract the feature from that image or from that recording, and it knows what it is, if it's a face or it's an object. So that image, we extract the features or the filters from that image. Okay, and we need to extract a feature for every color. Like if we have like let's say a grayscale image, we were gonna have a 5 times 5 times 1. But if we have like an RGB image, it's going to be 5 times 5 5 times 5 times 3, which the R and G and B, which is the red, green, and blue. So we have to extract every feature for each color. That's why we have like the convolutional layer, extract the feature number 1 and the feature number 2 and the feature number 3 based on the colors of that image. So that's what happens inside the convolutional neural network in order to process that image. So the convolutional layer then applies the red kernel, and then the red color image, the green kernel to the green color image, and the blue kernel to the blue color image in order to extract all the feature from each color that we have in the image. So if we're gonna talk about the generative adversarial network contains like a nested of convolutional neural network. Yes, it contains like a nested or multiple CNN inside the models, and it contains two models. So basically, the GAN contains two basic models. We call them the generator and the discriminator, and we are gonna discuss that or explain it later. But generally, the GAN contains like a nested or a list of convolutional neural network. But what happens in the GAN, we apply something we call transposed convolution, which means the reverse of the convolutional neural network. Like we saw earlier, we have like the large image, and the convolutional layer produce a smaller image, because like the convolutional kernel multiply uh, with the original pixels and produce like a smaller image. But what happened in the GAN, or in the transposed convolutional reversal, it takes like the feature and produce the image. So that's why we have the first layer, we have like a dense classifier, which is a layer to classify text or numbers, and that classification evolve within the reshaping and convolution and the transposed convolution in order to produce an image. So the convolutional traditional convolutional neural network, we take an image and we extract the feature from that image in order to give a label or annotation for that classifier, which is the dense layer. But what happened in the GAN, it's the reversal of what's happening in the traditional convolutional neural network. We take the classification and we produce the image using the transposed convolution, or what we call it, the up convolutional neural network. So basically, a generative adversarial network contains two main network. We call the first one, and they are mounted end to end. We call the first one the generator, and the other one we call it the discriminator. So basically, the generator produce a synthetic images or fake images, and the discriminator decides whether these images are real or fake. And in order to train the GAN, we go in multiple, let's say, levels. First of all, we provide the training to these. We train, first of all, we train the discriminator in order to uh, have the ability to know which one is real and fake by the training patch. Then we train the generator to produce like a synthetic images that looks like a real images, and the discriminator decides whether these images are fake or real. Then we apply something, we call it the misleading patch. The misleading patch, it's like they are all fake images, and we try to train the discriminator in order to detect which one is real and fake, which is the phase two of training the GAN. So the phase one, we mix the fake images with the real images, and we train that discriminator. Then in the second phase, we provide the discriminator with the misleading patch, which is a patch or a data set contains uh, all fake images. Okay, so let's try to write a code that can generate handwriting digits or synthetic handwriting digits. Does anyone have any question regarding the convolutional neural network or the GAN? I try to simplify all the information like in a couple of slides, but like there's a deep and complex mathematics behind all these neural network, and the type of the activation functions, and the types of all the equations. So I'm trying to simplify things for you guys in order to understand what is happening in the GAN, because the GAN like founded in 2014, and we are in the era of the GAN, and we heard about the deep fakes, we heard about facial recognition, we've heard about the new models that, like the GPT or Della, or what we call it, Imagine AI by Google. So all these our GAN models, we provide only, or we give it as an input the text, and it produce a synthetic image that looks like realistic or real images. So let's get started and try to generate the handwriting digits. Basically, convolutional neural network depends on the like, let's say the GAN depends on the most likely on the label in order to produce like a good images, because if we go to the unsupervised learning, or we go to provide like random images without extracting the feature of the images, we could have like distorted images at the output. So let's take that example here. I've already like established the code for you guys, because we're gonna take a lot of time in order to train it and see what is coming from that code, okay, or that script. So let me bring bifocal. So in the first input, we have the database of the handwritten digits. We could find it also online. In this dataset, and we could find it here. Like, it's an open source, and you can download it anytime and try to apply it in your code. So we have that hand writing digits, the database or the data set. In the first one, it just produced the downloads the database and stored in your PC. So once we click on run, we see that it's downloaded. So we have like the batch dimension, we have like over or exactly 60,000 images of handwriting, and we see the shape. If we remember the shape of the convolutional neural network, we have a 28 by 28, which means the 28 pixel by 28 pixel. Okay. So second of all, in order to feed that GAN agent, we have to remap these numbers again into between 0 and 1. We have to remap these values from 0 to 1. And we're not talking about the values, we're talking about the tensors that carry the values. So once we have these images, let's say we have a plane, like a simple plane, and we provide the custom preview, and then we take the RGB colors. So we have this, which is the last value here, 28 by 28 by 1. 1 is the alpha, or the brightness, okay? And since it's only 1, which means the images here are either a black or white, or they are grayscale images. So if we have like colored images, we would get like 28 times 28 times 3, which represents the red and green and blue. So all these colors move between like a 0 and 255. Okay, so if we divide that 255 by 2, we will get 127.5, which would remap these values of these images between 0 and 2. And in order to remap these values, the color values or the pixel values, we're gonna subtract 1 in order to have them between 0 and 1. So the original images, we have them between 0 and 255. We subdivide that by 100 and 127.5, and then we subtract 1 in order to have these pixels or the values of these pixels remapped from 0 into 1. And we reshape these tensors with a new value, which is the 28 pixel by 28 pixel by 1. Before we don't have like 1 here. So then we provide the tensors of the training data, and we need to connect the generator and the discriminator. We're not gonna dive deeply into the generator and the discriminator, and I'm gonna give you these as clusters. You could like explore them and see what is happening inside. But once you understand how to construct a generator and discriminator, you gonna understand what is happening inside this cluster, because they contain a lot of convolutional layers inside them, and the transposed, of course, transposed convolutional layer. So we see convolutional 2D, and we see another convolutional 2D, and we see the activation function most likely for the convolutional, or the convolution for the generators are most likely like leaky ReLU. Okay, and the activation function for the discriminator, it's hyperton. Yes. No, actually you cannot do that, because they will go into 0. That is what's happening inside these matrices. Once you understand how the tensors work inside the layers, you cannot just divide them like by one step. You have to divide and subdivide. You have to divide first, then subtract, in order to prevent having a lot of lost data at the end of the training. So basically what happens here, it's a lot of trial and error in order to get these like structure for this neural network. So now we have the shape of these by 28 by 1, and we're going to provide the generator and the discriminator. We could also save our trained model just by providing a path of your saved file, and save it in your PC. Let's say a desktop. Select a directory and have it on the desktop with a new folder. So now you would have like that. And the batch, the number of the size of the batch, the more like images to train that GAN, the more accuracy, but it would affect the memory, the GPU memory of your PC. If you have like a large GPU memory or large VRAM, you could apply more patches. But if you have like a lower or mediocre VRAM, you could apply like less patch sizes. And the epochs, we know the epochs, the cycle of the training. So this might take a while. So I will start the training, and we could see here the output or the steps of the cycle training in the command here. So once we start training, usually the convolutional neural network or the GAN needs like around 100,000 epochs in order to train very with a higher accuracy. But in matter of time, we don't have all that time, so we're providing like 1,000 epochs to see. And the more pixel or the high resolution image needs like a larger memory, of course, like larger GPU memory, and more and more epochs or cycles, training cycles. I could answer your question regarding the previous session right now because it would take a lot of time to train. So if you guys have any question, we could start with you, uh, Mehrzad, and tell me what was your question. So you told me that you faced a problem with the geometry or the Mandelbrot geometry inside Unreal. So what was the problem there? It's okay. Has anyone faced any problem with the Unreal?
Hello, Sam. Can you hear me?
Yes, I can hear you.
Sorry for the problem that I have. I couldn't log in with my laptop again. There was a problem that I had with the geometry file of the Unreal Engine assets. You know, I could play with the material.ussat. It was the format, I think. And also with the para file, but I couldn't import the geo file into the canvas of the Unreal Engine. I don't know, because I could change and alter all the colors and materials I wanted, but I couldn't see the geometry inside the Unreal Engine.
Okay.
The main canvas.
Yeah, that's like a normal issue, because the Unreal Engine is based on the C++, and it saves all the dependencies and the references once you establish the files inside your PC, because everyone downloaded the assets from the internet. It doesn't know which material to which geometry and which geometry to which material. So you can double click on the material instant, okay, which is the dark green.
Yes.
Okay, you would find that
Yes.
it would ask you
Yes.
on the right corner or the right tab, it would ask you for the parent. So just grab the light material, not the material instant, the other material, which is the parent material. Just grab it and hold it and put it on the parent material. That's number one. And number two, go to the geometry that you're having, and double click on it, and it would ask you for the material. Okay, just grab the instant
Yes.
and put it on the material. Okay, now grab the geometry. After that, just apply and save, and then grab the geometry and put it on the scene or the perspective, and let me know if it's
But the
working.
problem is that the geometry is only a the geometry is not the Mandelbrot shape. It's only
a
a
plane,
simple plane.
Yes, exactly.
Yes, it's a simple plane. Yes,
it doesn't
exactly.
know which material. All the code of the Mandelbrot is written inside the material. That's why it's not recognized. That's why you have to double click on the geometry in the content browser and apply the material on the right side or the right bar.
I did that. I did exactly like what you did on the session. But when I applied it and saved it, the changes that I made, it didn't went inside the canvas again. You know, I double clicked on the geometry file and did all the color changes and material changes as we did last session. But when I want to import it, drag it into the canvas, there's again just a simple plane, not anything else. Even after the changing the color and materials.
Try to do what I've told you, and let me know if it didn't work. We're gonna have like a private meeting, or I'm gonna give you to share your screen and show me what's going on.
Okay.
Did anyone face
any I'll try it.
other problem with the Unreal?
Basically, when I just
Thank you,
download the files, it's just giving me the upload are disabled because I need more access for the repository.
It's a public repository. How would you need more access? You just download all the file from the original one. Like when you go, let me just show you. Just go to the GitHub and sign to your account. It's gonna ask. Okay, It's 9. Okay. So just go to the repository and click on code and download the file. Did you do that?
I just entered the architecture intelligence. Then I start to download sessions.
You cannot download it from here. Unless, if you
From
want to
here,
download it,
file.
yes, you can click on the file itself and view raw. Okay, and it will ask you to download.
Thank you.
You're welcome. Did anyone face any problem with the previous session? Okay. In the next, okay, let's talk about the next example. The next example, we're gonna use the GAN, okay, with the dual attention generative adversarial network. And it's already there with the code written and ready to deploy. And you can train your custom data. What does it do? It takes like the segmentation or the label of every image and like produce a synthetic image based on your label. So once we apply like this label as an input, the GAN produce like a synthetic facade based on your label. So if we apply another label, it will produce a synthetic or a fake facade based on your input labels or segmentation. And they have like a lot of data set and pre-trained models. We have the cityscapes, we have the facade, and we have the ADE20K, which contains like a perspectives and interior shots, a bedroom, most likely it's a bedroom. Okay, we have the Caleb mask, which means the faces. Okay, so we're gonna learn how to download and how to apply this code and how to download the pre-trained model in order to apply it and provide our like custom segmentation in order to predict like a custom synthetic image for us. So we could just apply like our own data set and train it, and the GAN will produce the synthetic images or the fake images based on the trained data. Okay, so first of all, you have to download, for everyone who's going to continue with me on the machine learning from zero to hero, you have to download several application or software in order to be ready. One of these software, it's called Anaconda. With Anaconda is like a virtual environment that you can establish on your PC in order to work with machine learning without interfering with the virtual environment of your PC. So it does like a virtual environment for you. You could download all the libraries, all the packages, and establish a virtual environment for your code and deploy your machine learning without interfering or conflicting with the other programs on your PC. So just download it. It's pretty straightforward, and download the community version. Okay. And once you download it, you can. Oh God. Okay. Once you download it, you can just write on start and write Anaconda Navigator, and just start the Anaconda Navigator, and it will take a little bit of time. So now, once you open that Anaconda Navigator, we go to Environment, and we create a new environment. Okay? And once you create the new environment, you can add all the libraries and all the dependencies and the libraries and the assemblies that you need to deploy your model or to train your model. So once you apply it, just change it from the root or the base into your virtual environment, and you can just click on which platform that you would like to work on. So for me, I like most of the time, because I work on Linux most of the time, not Windows. So I choose the Jupyter notebook sometimes, and I choose the PowerShell and the CMD. Okay, so once you launch that Jupyter, it will give you it will open the local address, the local host, and you could just browse and say a new notebook, Python, and you could write the code inside these cells and debug or deploy every cell to see which one deploy successfully and which one report errors for you. So just if you write import torch, okay, it will go to a star icon, which means it's processing, and once it's finished, it will give you an output, or it would give you a number. Okay, so if we say torch to CUDA, which is the GPU computing or the GPU processing, so it would give you the output, and you can write your own code. Okay, and you could save it, and you can download it as a IPY notebook and share it, or you can download it as a Python and share it on GitHub. Okay, so I'm gonna shut down that notebook, say off, don't restart, get this out, and leave. Yes, absolutely. I'm gonna teach you how to install all the dependencies for the. Are you asking about the GAN? Dual attention.
No, about the Anaconda Navigator.
The Anaconda is an open source. It's available online. You can download it. But I'm gonna teach you how to install the dependencies. Okay.
Yeah,
or what you
about
need
that.
for the library.
So how usually I do it is using pip install, but I just need the names of all the dependencies. I'm not aware of all the libraries that we usually use.
It's okay. I'm gonna teach you guys how to install all the dependencies. So most likely, when as a programmer, okay, most likely let's say here, this is the the validating label in order to validate your model. So once we download, let's say which one. Yes, once we download it, we can see all the dependencies are written inside the requirements text file. Okay, so all the dependencies are written inside the text file called requirements, and in order to install them, you can install them manually, like search for them and install them, or you can just, I'm going to teach you. Okay. Okay, it's already running. Yes, you can just start the cmd.exe, which is the command prompt of your virtual environment, and as you see, you can see the name of the of your virtual environment written between the brackets. Okay, so cd GAN, and yes, it's a dir here, and we can find that file that contains all the dependencies that we needed. Okay, just highlight it and right click. It will automatically copy the name of the file, and you can just write pipe install -r and the name of the file, and it would automatically install all the dependencies. Okay, so pipe install -r requirements and the name of the file. That's it. You don't have to install them manually. And if you open the CMD, just the normal CMD, you won't see your virtual environment. And in order to start your virtual environment without getting into the Anaconda navigator, you can just write Conda activate CNTK, or the name of your virtual environment, and it would automatically activate it. Okay. It would depends on the assignment. That's what Midha asked me yesterday. So after these 4 sessions, it's an optional, it's not a compulsory, but it's an optional to provide an assignment of what you've learned. Like try to mix things up, or try to find an idea and apply it. And if you couldn't find an idea, you could just redo all these session by yourself and show it to me with the explanation as a video. So I'm gonna just select 5 participants, because I'm gonna put all my focus on these 5 AI architects. Okay, so once we finish this session, the workshop is over. So, and I will provide you the participation certificate, and then it's done. But it's up to you to provide like an assignment or an idea or something, or just redoing some of your favorite session, and provide a video explain what you've learned.
Okay, when the deadline to the assignment?
There's no deadline. Most likely it would be in September. Okay, so there's no deadline. I'm gonna take the advantage of the autumn and the winter, so it would be on September. So there's no deadline for that. Okay?
Okay. Thank you.
You're welcome. How many? Yes, I already. But it is up to you guys. Like what we say, first come, first served. Yeah. Okay. So I'm gonna like select 5 participants because, like I told you, my full focus would be on how would they learn the machine learning, and it will be for free, like I told you. Now, once we see that the discriminator and the generator get stuck into a value, that means either way, either the training is failing, so it would need more epochs or more training cycles, or we provided like an invalid data, so it's running into an infinite loop. And that's the struggle of training deep neural network. You don't know why it stopped, but just get stuck into an infinite loop or a loop. So it would just like gives you a value, the same value over and over. So either they reach the maximum or it's getting stuck. So that's why it's in the circle of researching between all the universities and around the world, the GAN, because it's typically a new invention to us. So that's why we focus on, and it has a lot of capabilities. Do you want me, guys, to give you a deadline for that assignment?
No, like you said, in September.
Yeah, in September we will start the course, but
Okay.
I would choose the 5 participant like before that. So do you want to have like until the 1st of August? Is it good for you?
I prefer mid of August.
Oh, come on. Between 1 to 3, like between the 1st and the 3rd of August would be great.
Okay.
Okay? So we're talking about roughly a month. Everyone is okay with it? So the deadline is between the 1st and the 3rd of August. Okay? So you have roughly a month to like study and ask all your questions and apply your assignment. And please, for everyone who hasn't made any account in GitHub, please do, because if you got selected into this course, we would have our repository as a private, and I would add you as a contributor. Okay, so you'd only see that. uh, what do you mean by levels are out? Have you clicked on the level that I've provided? It's like an orange line. You could go to the window and viewport. If you close the viewport, and if you apply a new blank level, you could just double click on the level in the content browser. It's the orange icon. So technically this session is a little bit boring, because that's what training a machine is. You know, you just have to wait, and you cannot do anything. Now, since we are training on the using the CPU, so we're totally fine. But once we train or use the GPU, like even the mouse uh, will be disabled, or you'd find a lot of lag, because uh, the training will suck all the memory of from the GPU.
So can we not use Google Colab or any online platform to train our models for GANs, or do we have to use Grasshopper?
No. We could use the Google Colab, and we could use a great platform called Kaggle. Have you ever heard about it, guys?
Yeah.
Yeah, Kaggle will give you like around, I guess, 36 hours of GPU computing per week. So that would be amazing. Or you could use like Google Colab and do your model.
Right.
I could provide you the also the GAN as a Google Colab file, so you don't have to install Anaconda and all this stuff. But in the next plugin that I'm releasing very soon, which is the Spider Engine, uh, the um, the torch or the PyTorch library would be embedded inside a Grasshopper, and you could use the GPU computing, because if we use the GPU, like if we use the GPU computing in that example, we've been like finished like around 10 minutes ago, but it's using the CPU, and the library here is called TensorFlow. And there's something I would like to mention during the training. There's something called the checkpoints. Okay, the checkpoints is when the model save the latest training, let's say phase. So if my laptop now crash, or the Grasshopper or the Rhino crash, I lose all the training cycles. That's why we established something. We will talk about it in the course. We call it the checkpoints. It's like the self-explanatory, the checkpoint of your training. So if your computer crashes or your PC crashes, you could just transfer learning, which is continue, give the model the continuation of learning from the latest checkpoint.
So now, can we use pre-trained models in a script? Like suppose it's a very complicated script, and is there a way or
Yes.
any availability of pre-trained models which can directly be used in the script?
Yes, basically every model or every an AI invention or deep learning, they provide the pre-trained model, so you can just predict fast without needing to train or retrain the model with the data set. That's why here we could see that we have the installer for requirements and all the dependencies, and see we have the dataset preparation. So these are the dataset for of every like component that they talked about. Okay, so and here we have downloading the pre-trained models. You can just download them. You don't need to
And
train.
can they be used? And can they be used in Grasshopper also? Like
Yes, that's why I'm saving. You see here, uh, here I provided the save, and
all right.
we've talked about the if you remember the second session, I guess, the second
Mhm.
session about supervised learning. We saved the model and just we loaded using the Lunchbox neural network tester, and we
Right.
yes,
Right.
we could just save our model and use it uh, whenever you want without needing to retrain the model every time.
And is there any limitation to like the data set that can be imported in Grasshopper? Like, suppose I download any pre-trained model on, I don't know, say videos or in like I can't think of any explicit data type, but is Grasshopper compatible with every type of data type pre-trained models?
Yes, it depends on the engine that you're gonna use. Here we're using the TensorFlow. Basically, TensorFlow uses the extension of H5. The extension of the file is H5. However,
Okay.
the space of that pre-trained model, but it uses the H5. And sometimes we use the pickle
Right.
extension of pickle PKL
Yeah.
uh, between different engines. Like if we use the PyTorch, it can like load the pickle pre-trained model, and if we use the TensorFlow, it can also load the pickle data pre-trained model. Okay, so it depends on the engine. Here we're using TensorFlow, so it's going to save as H5, and we
Right.
could like change that extension to pickle using the pickle library and have it
Yeah.
on our PyTorch or any other scilern or cognitive toolkit, whatever you want.
And one last question.
Yeah.
So, will you also be covering deployment in your course that which the one that starts in September? Like, how can we deploy our models online or on a web?
Yes, yes, surely I will.
Okay.
I will cover that. Also, I will cover like building a solution, which means an executable file or a website.
Right.
So
Right.
with your pre-trained model. Okay.
Thank you.
So
Yeah.
you're
Thank you.
welcome. So we're gonna cover the most likely the back end of the machine learning and with a little bit of front end, like an executable file using the .NET Core and the machine learning .NET framework and as executable file. And also we're gonna cover the HTML using, I guess, Django, if you heard about it.
Yeah.
Yes, we're gonna cover all these libraries and dependencies. Yeah, these are the dataset that I've talked about earlier, the process data and the dataset of the plan, if you remember, guys.
Yeah.
So I'm still wondering about the how would I provide all these data to you, because it's around like 300 megabyte.
Maybe Sam, you can try a WeTransfer. I think somebody suggested it yesterday. So you can transfer up to 1 GB of data for free on using WeTransfer.
Yeah, is it for free?
Yes, yes.
You see here, these are like around 80,000 plan. That would be amazing. Retransfer.
Ideally, Sam, do you recommend the size of a data set, like it should be minimum this or maximum of this size for a model to train? Like, do you have a minimum, do you have a number?
Yeah, technically, if we're using like convolutional neural network, we're talking about over 10,000 to 20,000
Okay.
images. But if we're talking about numeral things and we're talking about like values and stuff, we could
Mm-hmm.
say like around 200 to 300. But the more, the more data set, the more accuracy. But the minimum of the CNN, we're talking about like a 10,000. Okay.
Yeah.
So now the finally the GAN engine has finished. So now we can see we're using the out plugin. I will upload it today to you guys so you can use it. So now we can see how the data tries. We call that transformation. We call it the truncation movement. To move between an image to another image, we call it a truncation. So since we're having like a little tiny image as how many pixels that we discussed? We're talking.
28 bit.
Yes, thank you. 28 by 28. That's why the image is not clear, and we provided like 1,000 training cycle. That's why we're not seeing that clearly. But once we provide it, that movement between the numbers, we call it the truncation movement. Okay, we've heard about it. We've seen that like that style in a lot of GAN, like that GAN that transfers from face to another face. We call that truncation. Okay. So now we're seeing that truncation of these numbers, and we could use like these are not random values, and we provide it to the generator. Okay, since now we have it as from 0 to 1, that's why we're using the range from 0 to 1, and we could just try different seeds to see which one. It didn't give me accurate results because it got stuck, remember, here. So now we're just visualizing the tensors, and we're reshaping it with the 28 upon. Okay, so now we are reshaping that tensor, and we see it in the tensor 2D preview. Yeah, where did I save it? On desktop as a new folder. Okay, let's check it out. New folder, HD5, yes. That's what you asked me about, right, Midha?
Yeah.
Yeah, that's the pre-trained model. Okay. Now let's jump into the last example, which is the Anaconda. Now here in the Anaconda, we go to the dataset. I've downloaded the Facade, and we go to validation images. We find that we've chosen that style, okay, to generate a synthetic data, and we give it like a custom label in order to generate it. So if we have like that label, let's say this one, we need to make sure that the resolution or the dimension of the pixels must match with the validation image. So we have 1024 6. See, it's 1024 6. So we could just change it on Photoshop, or I could write a Python script for you to change it easily. So if we provide that, it's 62. So we go to image. Just like that. Okay, and we could just save it on the desktop like 0. Okay. Now, if we go to the label and delete that, and we having here. Then we go to the results. Do we have any images? No. Do we have any synthesized images? No. Now we run the model. We make sure that we have the pre-trained model of the facade, this one, PTH, which is PyTorch. Okay, now just we run the script. There's the command is ready here. You can find it on the test facade, or you can enter it manually. Once you open it, it will give you the command. They have written that command on a shell because they were using Linux. So Control C, and we go to that file, and we click on Shift and right click, and we open PowerShell window here. And how do we activate our virtual environment? By just clicking Anaconda, activate CNTK, activate. Oh, it's not. I haven't installed it on, so I would need to a CMD. So there. So and activate CNTK, and we just run the command here. So it's going to save using the dataset facades, the data root, the dataset facade, GPU. If you have more than GPU, you could just like add a comma and add how many GPU you could use. I have only one GPU. The result at the result directory, the checkpoint at the checkpoint directory, the batch size, we have one image, and the epoch is 100. Okay, so see now. We just wait a couple of seconds, and because we're using a pre-trained model, it will process the image directly. And now it's loading the pre-trained model. And and we could go to results, images, synthesized image, and see what is happening here. And if your window got stuck, you can easily click Ctrl C and repeat that and try to do it again, but it's reloading all the pre-trained model. We could go and grab another sample from the dataset and grab like another label. So let me just did it bring the result? I believe no, because I canceled the. So let me try again. See, I just repeated the process and it tries to provide a synthetic image based on the label. Okay. So let's try to take a different label. Is it the same one? No. Okay, let's try to take a different label, and I'm gonna resize it again. Sorry, I'm gonna resize it and image. I guess it was 762, right? So resize it and we call it 1 on the desktop. Yes. We could automate the resizing like I told you before and provide it to the dataset, facade, validating image. I believe it's the same one, so I'm gonna take another one from the dataset, validating label. Let's take this one. Okay, put it here and try to resize it. Image size 672, I guess. And we can call it 1. Yes. Now we just put it on the validation and delete this one and run the command again. Okay, let's see what's going on. Yes. 762, we need to provide the same name, sorry. Okay, so if we go to the results, synthetic, And let's try to get the last one from the dataset. Let's see this one. We want a landscape. No. They need to have the same, we call it the same dimensions, okay? I cannot provide different dimension. Like, it's going to the first image, to the real image, and takes all the features from the real image and try to see what to apply on the label image to provide the synthetic, or to give me the synthetic image. So they need to have the same dimension, okay, which means the same vertices. We could just make a small program or small code to give it, to resize the image and take all the labels from the Rhino. Okay, so since it got stuck, so I'm gonna Control C to abort or to interrupt. Okay, so let's take this one, take it here and provide it to is it 672? Oh, okay. That's what you were talking about. Okay. I gave it like a wrong dimension. That's why it got stuck. So we have this one, and we could just go to the image size 762 and save it on the desktop as 3. And get the old one, which is number 1, and go to the image size 762. Okay, save it as number 1. Now let's go to the it's taking forever. Okay, I'm gonna give it a little bit of time for canceling that. Okay, so once again, we're going to the CMD and we enter that. Okay, and we provide that. And before, could provide the new one with the right dimension. You see different results from the old one. Let's say we try a different one. Make sure they have the same number. And we go to the results. We're supposed to have a different result from the old one. Now, if you wanted to change the style, you could just change what style you want here. You could go to the dataset and the validation and change that. And to change that, I'm going to provide you with the validation images. You could just choose whatever style you want. In order to mimic an image or synthesize an image from that style, different facades. you have around 300, but each one has like a different dimension. You have to pay attention for that. Oh my god. It's sucking all the VRAM from my GPU card. I do recommend to have like a VRAM of like 12 gigabyte or more in order to do that, if you have one. Does anyone have any question? Because we're gonna wrap up after that uh, deployment. I should have done it on my other PC. It's okay. How? How would you implement unsupervised learning for that type of prediction? Yeah. So most of the unsupervised learning, it's to cluster. You could cluster these decisions and then run a supervised model in order to predict these decisions. So basically, you can cluster them if you have them randomly using the unsupervised learning, then you can classify them and predict these using the supervised learning. But the unsupervised learning to predict all these, it would be like really, really hard to do that. So that's the problem with with deep learning and the GAN. It takes all the processing and all the storage from your GPU. See? Okay. Does anyone have any question before ending this? Do you want me to provide all the pre-trained models to you guys? Okay. Okay. I hope you enjoyed this workshop. I hope it went well, and hopefully